So we've got an irrigation system with a center pivot. Can you imagine that? One point is fixed and it can rotate around, and that's why if you fly over certain places they got perfectly green circles, because they've got irrigation systems that can water things in a perfect circle but nowhere else. One system has an arm 36 meters long. The speed of the end of the arm is 3 meters per minute. That's how fast the end of the arm is spinning. So if we draw a picture, we've got 36 meter arm here. The speed at the end of the arm is going at 3 meters per minute right there. So sometimes it's important to measure, to draw, to get an idea, a picture in our mind of what's happening. What angle will the arm have rotated after 30 minutes? So if it's starting here, can you see in 30 minutes it's going to have traveled a certain distance? How far do you think? Is that too far? Does that look like more than 90 meters? Okay. So just tell me when you think I should stop. So we'll say that looks like about 90 meters. How did he know it was 90 meters? Okay. No, you're talking about how you knew how far it was, but how did we know to begin with that it would be 90 and not 70 meters? Because it doesn't say 90 in the question. So we got 30 minutes and it's going 3 meters every minute. So in 30 minutes it's going to travel 90 meters. So now we're trying to find this angle theta. What do we know? We know we have a portion of the circumference. So what you're going to do on your exam and on your test is you're going to go right to your formula sheet and you're going to pull up your formula for arc length in radians. Okay? What I would hope that you would do a year from now, because a year from now I'm going to ask you, if I meet you on the street, you're going to say, "Hi, Mr. JR," and I'm going to say, "What's the formula for arc length?" And you'll go, and you'll forget, right? Of course I'm not going to say, I'm going to say hi back. I'm going to be nice. But if I did that right away, out of context of the math class and not having taken math for a year, you're going to forget that, right? So I think it's kind of nice if we start off with the formula that you guys created, right? An arc length is a portion. It's a portion of 2 pi, because that's how much is in a whole circle, and it's a portion of the entire circumference. Now, if you do that, it's pretty easy that these cancel out, and here's your formula from your formula sheet. We went over that yesterday. So there's our formula from our formula sheet. Now, we know the arc length. We know the radius. How hard is it to figure out what theta is? So the arc length is 90. We don't know theta, but we know the radius is 36. Divide both sides by 36. Simplify. 10 over 4, 5 over 2. They both divide by 18. And so our angle is 2.5 radians. Then, at this moment, how far will the end of the arm be? So this is where it is now, after 30 minutes, from its starting point. Where is its starting point? Right here. What are we trying to find? This distance. What did I just make by drawing that dotted line? A triangle. Tell me everything you know about that triangle.
The two sides are 36.
Good. This side also is 36. And now instead of theta, what can I write here? 2.5. That's the angle. And if we do just an estimate, remember 1 radian is about 57 degrees. So if we did 2.5, 2 times 57 plus a half, well, maybe we'll use 60 because it's easier to do multiplication. 60 plus 60 plus 30 would be 150. It's going to be a little less than 150, so maybe 145. Gives us an idea of how big that angle is. How do we solve for x? SOHCAHTOA? No, why not SOHCAHTOA? Not a 90-degree angle. But it's in radians. How do you, oh yeah, we figured it's about 145. Whew. Okay. Sine law. What do we need to use the sine law? In order to use the sine law, you need an angle and its opposite side. Anywhere in this one, do we have an angle and its opposite side? That we know. We have an angle. Do you know what its opposite side is? No.
But we can figure out the opposite side with an isosceles triangle.
How do you do that with an isosceles triangle? Because the opposite side is going to change depending on the angle. Well, we could figure out, yes, that is true. So we could figure out this angle because it's isosceles and both of these are equal. Then we could figure that side. Then you could use the sine law. Good. But if you didn't see that, because sometimes you don't see those things in isosceles triangle, what else could we use? The cosine law. If you look, have I given you formula sheet yet? No. Oh, I'll give you a formula sheet today. If you look on the formula sheet that I'm going to give you today, you're going to find out the cosine law and the sine law are not on there. So they are now in your assumed knowledge. You learned it last year. Now we assume that you know how to use it. Okay? So assuming you know the cosine law, which looks like this. Yes? So familiar. Right? You know that just as well as y equals mx plus b. Good. Now we want to find out this. We know that both the other sides are 36. Cos A, but now A is 2.5. So when we go to type this into our calculator, the only thing different that we're doing now in grade 12 than what we did in grade 11 is we're using radians instead of degrees. But your calculator, you can't just say use radians instead of degrees by talking to it, although maybe there's some fancy calculators you could. We're going to have to make sure we go to our mode and change from degrees to radians. And now we can type this in, 36 squared plus 36 squared minus 2 times 36 times 36 cos 2.5, enter. And that's equal to a squared. So how are we going to find a? We're going to have to square root our answer. And it is 68.3 meters away, approximately. Is that what the answer in your textbook says? I sure hope so. Otherwise, I'm going to have to take the rest of the week off. Is it? Yeah? Okay. I hear some disappointed sighs. So there was the cosine law, figuring things out. We dealt with our arc length formula in this one. Now I'd like you to try the one off to the side and see how you did. And in the homework, 8 and 9 are ones that you can do, but we'll try the one off to the side first.